We're live on the air. Live, it's Saturday night. Huh? Huh? I don't know. I don't really watch it.
I have a friend who's from London and is visiting the States right now, and his phone got one of those like emergency warnings, and they don't have those in London, so he's never got one before.
Yeah.
And he thought like the world was going to explode. It's funny to see.
That's pretty good.
You were smart.
Yes.
Yeah. I feel like every day now, like you said, look at it. Every single day, just bring one with me. Might rain, it might not.
Yeah, but climate change has like shifted the seasons a month.
It was 100 degrees.
Yes. She's no longer with us.
And I will not isolate myself. I feel like they're not structured.
No, they aren't.
I like to
Bubble umbrellas do a little better, but they're really unwieldy.
Really? I never used one. What do you mean they're unwieldy?
Because they don't, like this one, it's compact, but the bubble umbrellas are like long, can't contract into a smaller piece. Yeah.
You mean the bottom umbrellas are like the clear ones that are like this?
Yeah,
I mean you can't like.
So like that one, when you close it, it's like short.
Yeah.
That one, you close it, the bubble umbrella, you close it, and it's long.
Oh, just like the
Oh, so
old
you
ones.
can't-
Yeah. They figure it out.
Yeah, exactly.
Outside of whatever.
Yeah, so you carry it like a cane.
I mean, I tried this like a cane. It's just like short. No, that was super.
I actually like that. I like they just use it as a cage. Use my
We're all like, okay. Nobody knows what to do with that. Does it help you walk? Like,
No, it's literally just because I didn't get it.
oh, okay, because you said easier walking, and
It's
that's
like-
what threw me.
It's like a pure.
Okay.
I see like old guys like just doing it.
I mean,
That's what it makes me think of, and you're like, yeah, I'm gonna be this cool one day.
Yeah. I just see them like they got it like perfectly sort of casual. My day.
Maybe not a casual drizzle. He's gotta feel cutting or two.
Oh god, yes. Summertime is just a big fluff.
Oh my god, my friend said like the dumbest thing about curly hair I've ever heard in my entire life. Apparently one of his previous female friends had told him that curly hair, like I don't know what she said, but like I think he misinterpreted because he believed that curly hair is curly because it's drier, and if you like moisturize your hair, it'll be straight.
Wow.
Yeah, I'm like, that's not true at all.
Wow.
It's genetically curly. Wow. I assume she said curly hair is drier than straight hair, which is true.
Is it?
I think it's probably true. Like curly hair tends to be thinner and more like breakable.
That's
And
not true though. Because,
I mean, obviously it depends on the person.
yeah.
That's what I've heard, and I'm sure everyone who listens to it because it's true for me. Like,
Yeah.
it's definitely better than
Mine is.
so it like requires different care, but like correlation and causation. That's where the whole communication worked out. It's like, oh, so if you just like sat your hair in like a pool of water, it wouldn't just like fine straight.
Oh yeah, absolutely. That is pretty much the opposite. Yeah.
Okay.
Morning text.
I assume I've learned everyone's name. I mean, there's not that many people in this class, so I learned everyone's name.
I don't know real, I don't know anything. Flax for, oh my
Yeah.
god, that's so true, that's exactly what flax for. So they never uploaded.
I know what you look like. That's okay.
Creepy. Oh, I just said you know it.
I know what you look like because you're 2 feet away from me. Hey, Lars. Definitely very outside. Basically, my
Okay,
girl
shower.
shots, I have 2 minutes to show up. 2 minutes to my office. Yeah, totally. The trains, I never understood, the trains cause subway delays, or the rain caused subway delays. The trains are underground.
I think it's
Oh my
the
God.
less than time.
Yeah.
But like,
Or there's like.
I think people are slower in it too.
Oh,
Yeah,
yeah.
I really
cars are worse than mine. But like, why the stuff, I don't understand why subways are. It's like, I get it if something flies and.
In fairness, some ways are effective. They could be like, here's a butterfly flap, 20 miles from
See,
here.
that's what I'm saying, is they're so over dramatic, they're like, a raindrop got onto the tracks. We must stop service.
I remember a friend of mine sent me like a video of the E train was literally like pouring inside, like
It's,
that thing. I'm sure somebody else saw that video, but like my friend just sent me like, yeah, you can never convince me that New York is better than any other city. It's just like casually flooding around for
that's
us.
why we love it.
It's exclusively our problem.
The situation, it's like, it happens like 2 or 3 times a year.
Yes.
Like, it's just totally fun. It's like-
Yes, like just casually, like DC, surprisingly, DC's 4.5 subway lines, they flood regularly every day. Just like, yeah, like, it's good, but like we're a little bit more exclusive.
I'll give them till 6:35 and then we'll start, because we've got a quick lesson today, so.
Excellent, I work on like 2 hours of sleep, so.
Your professor just finished his talk in Boise.
Is it his new favorite place he's ever been?
Oh, yeah. There was a conference, like a DevOps conference, and he was talking about serverless environments.
Maybe something that will.
So, while we're sitting here, next Tuesday, Taki's current class is presenting their final project. Would you rather just come here, learn about loops, continue as normal, or would you like to see their final presentations to get an idea of like what kind of outcomes you can expect to produce?
Why don't you take something to be like online, see as well? Like the class, like this isn't a long class, I don't want to like waste.
Oh, yeah.
Waste, but like
Yeah.
10 minutes, like,
Yeah,
you know what I mean?
that's why I'm
Yeah,
letting you choose.
yeah. But if they're
don't-
going online, that would be,
Think they go up online.
okay.
Yeah.
They might,
Oh, and
not immediately for sure, but they might. So, but yeah, I totally understand.
I just like it, so,
Yeah. Okay, we can take a poll on this.
yeah.
Okay. So if everyone wants to open up homework 1 from last week, we'll just go over those 2 problems really quickly to start. The shopping list calculator, which should be ridiculously easy by now with everything that we've learned. So it's just to create 5 variables for some shopping list items, another for their price, another 5 for their quantity, and then printing them in this format. So really just to practice creating variables of different data types and then formatting them as strings. And what I added here actually is an extra little trick with the format function. And this allows you to round to 2 decimals, or whatever number of decimals you choose, 6, 12, any number of decimals you choose. So here what I did when I calculated the price, I did the math and then formatted the result so that it would round to 2 decimal points. And then the outcome looks like this. And it's exactly the same thing for problem 2, except that you use the input function to get user input. Now, something worth note here, I noticed this on a couple people's homework. The input function always returns a string. So if you're expecting them to put in numerical data, you have to convert it into either a float or an int once you get it. Otherwise, you'll get an error if you try to do math with it or something like that. So for the price and the quantity input, you have to convert them to floats and ints first. And then I just did the same thing when I did the math. I used the format function to round it to 2 decimals. And it outputs pretty much the same thing, although I'm not going to take, does anyone want to run through this and put in 15 lines of user input? I don't. Okay, super. Onwards. Any questions about these problems? Okay, sounds good. All right, so back to our lists note page. We are just finishing up the topic by talking about 2 data structures which are very similar to lists, tuples and sets. Tuples and sets are both essentially lists with a few idiosyncrasies which make them useful for specific purposes. So tuples are immutable, meaning you cannot change them after you've created them. Tuples are denoted with the parentheses instead of the brackets. And you can declare them in two ways. So you can declare them literally like we did with the list where we put the values straight into the brackets. You can do that here with the parentheses. Or you can put a comma between the two values and no sort of container, and it will automatically interpret it as a tuple. Like this. Tuples don't have to be a certain length. They can be any data type. The only thing is you can't change them. You can index them so that you can read them like a list. So for instance, and you can nest them as well. So for instance, here is DNA, ATGC, right? So you create a tuple. A and T always match together, always, 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 always. So you put these in a tuple, you put G and C in a tuple, and then the whole thing is just itself another tuple. Makes sense because they always pair that way. So you can access them the same way with the brackets. So if we wanted to access the first item in this tuple, which would be AT, you would do 0, right? Because index position 0. If you want to access the first item in the second tuple, which is what this example is, you would put 1, because index position 1 in the parent tuple, and 0 because it's index position 0 in the inner tuple. So then that would print out like this. This is the whole thing. This is where we printed this whole thing. Questions about that so far? All right. You can do some of the same operations on tuples that you can do on lists, even though they're immutable. So for example, you can do the length, sum, min, max. You can do count and index. And they work exactly the same way. You know, dot count and dot index are formatted like this, whereas length, sum, min, max go on the outside. And they print out just like that. But there are a few limitations on sorting, joining, and splitting. So for sorting, remember last time we discussed how dot sort and sorted, the difference between them is whether or not it changes the list in place. And some functions do that, some functions don't. So dot sort is one of the ones that changes the list in place. And you can't do that with tuple because it's immutable. So you can't use dot sort. The others, yeah, go ahead. I think it returns an error, but let's just do it. Yeah, has no attribute sort. Okay. The other thing to remember is for join, split, and sorted, you can do them, but they'll return a list. So the tuple that you created before, in this instance, tuple 2, will still exist. It'll be exactly the same. You can reference it exactly as it was, but then it will output, each of these will output a new list. So for example, here's sorted, ascending and descending, and then joined and split. We use the same syntax for each of these as we did with lists. Questions? Yes?
Can you just reassign that to be, can you just recategorize that to be a tuple? Or vice versa?
You can, yeah. So if you want to then turn it into a tuple, so let's say split up. Let me just comment these out so that we're not getting a lot of clutter when we print. Oh, it would help if I printed that.
So you can change it back.
Can you nest it? You do the operation with the tuple function and then like have an auto.
What do you mean nest it?
So say you're doing sort.
Uh-huh.
You do a tuple.
So like this, you mean? Like whatever
Yeah.
comes out of sorted?
Yeah.
Yeah.
Just kinda like skip the whole list. Right?
I don't know. Let's find out.
No application.
Oh, and you have to. Oh, always good to figure these things out. Yeah, so that works. But also, what I'd like to see what we did here, how tuple, we didn't reassign tuple 2. So I don't actually know if you wanted to make this tuple 2, or here, I'll just put this on a separate line so that we can still keep that example. If you wanted to make this tuple 2, I'm not sure that it will work because tuple 2 already exists as something else.
So we're trying to like
I don't,
use sort.
yeah, like you've created tuple 2, and now because it's a tuple, I don't know if you can overwrite the value that's stored within the variable tuple 2. So let's find out. Oh, look at that. Apparently you can.
So it kind of just works as sort anyway.
Yeah. I'm actually curious about that. That's very odd. So not completely unchangeable.
Like, what change?
Yeah. That's so weird. All right, well, yeah, if you try to do something like, for instance, like appending an item to it, that won't work. So if you do like tuple 2 dot append f, it won't work because you can't add or remove or replace items like that. So I guess maybe the distinction there is you can reassign the variable as a whole, but you can't add individual items. You know, like you can make that variable equal to an entirely different tuple, but you can't edit that tuple in place, I guess would be the distinction. Any questions about tuples right now? That's pretty much the extent of tuples. Okay. So moving on to sets. Sets are denoted with the curly brackets. They're similar to lists, except that they can only have unique elements. They are mutable, but order doesn't matter for them, which is why they can only have unique elements. So for example, here you see set 1 and set 2. The only difference between set 1 and set 2 is that, or as we declared them, is that set 2 has multiples of each of these numbers. But if you print them out and you check whether they're equal, you'll see that both set 1 and set 2 are only 1, 2, 3, 4, 5, because you can add these duplicates here, but it will just interpret it as, you know, the single value for each one.
It will only take the first one, or like what if there's one at the end?
If I have one at the end, it'll still just interpret it as one.
Okay, so it just ignores duplicates and takes
Yeah,
I was wondering what the order.
yeah. Also, that being said, so like here, set 1 and set 3 in reverse order from each other. But here, we'll print them out. Also equal to each other.
Oh, so the order doesn't matter.
Yeah, doesn't matter at all.
It automatically works.
Yeah, it automatically ordered it, no matter what you assign it. So that's actually a really important point, because given that the order doesn't matter, that means that you can't reference any of the items in a set by index position, because by definition, they have no index position. The only way that you can do that, or like reference whether items are in a set or not, is to use the Boolean membership operators that we learned about 2 classes ago, I believe it was. So for example, here we have set 1 again. You can do, is 2 in set 1 true? Is 8 in set 1 false? You can chain that. But that's the only way to check whether those values exist within the set. That being said, you can still perform math and do some of the same operations on sets. So again, length, sum, and max. You can do count. There's no index though, so you can't do dot index. And you can do sort, join, and split, but you have the same limitations as a tuple. So you can't use dot sort, and when you use join or sorted, join, or split, it returns a list. Same as before. Or actually joined returns a string, but does that make sense? Joined is a string because join, you start with a list and join them into one. And split does the opposite. You start with a string and split them into a list. Yeah. Questions on sets at all?
Why is that the order?
Sorry, why is what the order?
All right, if you can't order a set, why does it start with C?
Here?
Yeah,
Mhm.
why is C the first one?
You know, I'm not 100% sure about this. Taki could definitely answer, but I think it has something to do with the way that it's stored, that it's variable, the way that it gets stored, so it can get printed.
If you run it again, will it potentially run it?
Maybe. I'm not sure of that answer, but
No, it's just running the same way over.
yeah,
I don't understand.
I don't know.
There's one access for you.
Yeah, I will look that up and get back to you. Other questions from anyone? No? Okay. I did, if you remember, create this summary table, which I think is extremely helpful because for me, it's really useful to see like right next to which properties each of them have. So this will probably be your best friend. On that note, we can do some practice problems, but let's try one together first. So our practice together problem, the prompt is to remove the duplicate items from this list. Does anyone have any ideas about where we might start?
What if we're changing to a set?
Yes.
So you do, I'm sorry, just.
No, take your time.
You just set the things and then find it.
And you have to reassign it, remember,
Oh, okay.
because it doesn't
Right.
change it in place.
That's great.
Well, actually, it will be my set after that, but sure.
Right.
It's a call by list.
What?
He said print by list because it's still called.
Yeah, that's what I was just saying, technically, it's not my list anymore, it's my set. Yeah. Let's call it my set. And then we can print it, and all the duplicates are gone. I think that's a nice one. So, yeah, sets are very useful for that purpose. One of their best purposes. Um,
Excel. So much easier.
Yeah. And then you can, kind of like we did with the tuples before, you can convert it back into a list if you want. So we opened this link before last time, so if you still have it from last time, your notebook with the P sets, or no, we didn't start the list P sets, so go ahead and open this one, make a copy for yourself, and let's take maybe, let's say 12 minutes to do the list ops problems. That's 4 problems. Last time we did 4 problems, people got most of the way through in 10 minutes, so I think 12 minutes sounds about right. Yeah? Okay, so,
Which link was this now?
sorry?
Which link was this?
Right at the bottom of the notes, this list the class practice P sets and this link. So I will set the timer for 12 minutes, and then if anyone has any questions, just let me know.
about at the halfway mark. Is everyone on track-ish?
On the second one.
Okay. That case, I will add just like 4 minutes. Sounds like that's probably, everyone will finish within that time.
30-second warning. Don't freak out. We'll just go through them together after this. All right. I don't think you probably didn't hear the timer, but it did go off. So, did everyone get to a decent point, like at least problem number 3? Okay, so then why don't we start going through these together, and then that way we can make sure to get through to the rest of the lesson, because that way you can do the homework. So for the first problem, basic list operations 1, it's very similar to the practice problems that we did together in the last class. Pretty much just creating the lists, accessing different items, adding, removing items. So for part 1, it was just creating a list with these 5 animals. Part B is printing the 4th animal on the list. Again, since index starts from 0, the 4th animal is index 3. That's how you reference it. If you want to add tortoise to the beginning of the list, you would insert it specifically at index 0. Why can't you use append for this? Sorry, like 3 people at once here. Why can't you use append here?
It adds each individual letter, like, as its own.
Close. That's extend.
Oh.
Append adds whatever item you pass to it to the end of the list. So if you want to add an item to the beginning of the list, you use insert, because insert allows you to specify the index position where you want that new element of the list to exist. If you want to print the length of the list, simple, just len, and then the name of the list. If you want to remove orangutan from the list, you would do pop and then orangutan's index, which is 4. And if you want to sort the list alphabetically, you can use sorted or animals.sort and print that. So if we print out all of this, I've got the letters for each of these next to the answers, you would get this. Questions, anyone? And again, I will share this link with the answers to these questions on Slack once we finish. That way you can go over them on your own time. So the second question, similar to this, declare a list with 5 names and print out the length. Print the third name on the list. That means you would pass it index 2. If you want to delete the first name on the list, you would do .pop 0. If you want to re-add that name that you deleted to the end of the list, that means you would have had to assign that name to a variable when you popped it out of the list. That way you could print the name that was removed. And then you could reference that in the next one using .append that name that you removed. What?
Yeah, that's what
I just re-edited this right.
Yeah, well, that's why we go over these together in class. That's why you'll have the answers so that you can look at these solutions. And you still got to the right endpoint, right? So it's all about, like, as long as you got to the right end, fine-tuning is with experience.
Yes.
The more you write, the more you'll fine-tune your code. For part E, replace the second name on the list with a new name. You would do actually, did I do that right? Insert 1 Natasha. Let me see. I might have done that wrong, because if you want to replace the second name, you probably oh, this is missing. All right. So re-add the name you added at the end, that's here. And yeah, this does not replace it. So if you want to replace it, how would I do that instead of just inserting this name?
Would you just like reassign it to some names, bracket equals?
Yes, exactly. And if you want to add 3 new names to the end of the list, here's an example where you would use the extend function, or where it would be efficient to use the extend function, because you can say, you could actually do something like this, where instead of having, like, passing these 3 names individually, you could do something like this, where you just have another variable that contains a list of the new names and pass this variable. So you could do it this way, probably faster. What?
I just did names on ends 3 times.
Oh, yeah, well, like I said, that's why. Hey, but that's why you have these examples. Like, practice, practice, practice is the name of the game for code. The more you see these solutions, the more you write them, and then you'll get them. You'll make your own life easier. For number 3, we'll do some math. So save a list with the numbers 2, 4, 6, 8. Print that out. If you want to find the max of the numbers, you do max numbers.
Sorted it, and then I chose the last one.
Again, like, you'll remember more and more of these, and you'll be like, oh yeah, there's a much easier way to do this. So, still good. You got this. You achieved the result. Okay. Part C is to pop the last element in numbers off and reinsert it at index 2. So again, here's where you could assign that popped name. And because it's the last element, you don't have to insert any index position into .pop. If you assign this to the variable removed when you do it, then when you insert it back into the list with .insert index position 2, you can just pass in this variable rather than the string again. Yeah. And then you print out the resultant list. If you want to pop off the second number in the list, that's when you would pass in index position 1 of the second number. So the difference here is if you don't give pop any argument, it removes the last one. Otherwise, you would have to put it in the index position of the one you wanted to remove. If you want to append 3 to your list, you would just do .append 3 and print out the average number. This one here, all you have to do is find the sum of numbers, find the length of numbers, and divide them to find the average. There is no average function.
Try like an average of that.
Yeah, so sometimes you have to just use the simpler functions to create something like this. Yes?
Is there a way to see what functions are available in the module? That module?
Yes. In this case, in Colab, no, so you would just look up the docs. But if you were using Python in the console, there's a command, a help command that allows you to see which functions are in the module. In Colab, no, though, you would just look up the docs. But you'll see the console later in the class, and then, yeah. Questions on this one?
What's your average?
The average was 4.75. Yes. So then ordering random numbers, a callback to the random module that we learned last class. If you want to create a list of 6 randomly generated numbers and then sort it, you have to import our friend the random module, specifically the randint function. What we did here is I did have to run this function 6 times and add each number to the list. I created a blank list, then generated this number and added it. Here's an example of where you would use something like a loop to do this once we learn the loop so that you don't have to do this 6 times in a row. 1, 2, 3, 4, 5, 6. Help me. All right. Good eye. Anyway, so here, if you were to do something like a loop, you would write a loop such that you only have to write this line 1 time, and your loop would know to execute this line 6 times. So we'll get to that next class. Then I printed the unsorted list and then used .sort. Notice how I didn't reassign it to a variable because .sort edits the list in place. And then I just printed the sorted list. So the outcome would be this, or any random. Actually, it won't be this for you. It'll be any random set of numbers. If you run it again, it'll be different every time. Questions on this one? Okay, Right. Would you rather take your break now or do the introduction to dictionaries and then take a break later in the class today? Break now? Okay. All right. 7:28, let's say. Be back. Oh, and I forgot to introduce the most important VIP justice, half brother. They're twins.
I know what that is now.
All right, I sent you guys the link with the answers from the problems that we just did. Yes? Oh, so I can reopen that. What's up?
The last because you're doing random numbers, just store, and I just want to make sure I'm following where it stores the numbers.
So
Every
it's
time you run it, it's essentially give you the numbers.
yeah, yeah, it's stores the numbers temporarily.
For that time.
Yeah. Yeah, I mean, if you did something like you saved this list to a database that was elsewhere, then they'd be stored beyond running the program at that time. But otherwise, yeah, it's just during this. So if everyone goes to the lecture link that I sent in class for lecture 4, and open up the Dict notebook and make a copy, we can start with that. So dictionaries are pretty much exactly what they sound like. They're a way of mapping one piece of data to another piece of data and just storing those pairs in a group. So we call them key value pairs. And this is what a dict looks like. It's also stored in the curly brackets, and you put the key first, separated by a colon, and then the value. And if you were to have another one, you would do this. So you have a comma in between the two key value pairs. The keys and the values in a dict don't have to be homogeneous. They could be anything you want, any data type, mix and match. But there are a few rules for keys specifically. Dict keys can be strings, integers, floats, booleans, and tuples, and sets, or tuples. But they cannot be lists or dicts. So the distinction here is that your dict key must be immutable. And since lists and dicts are mutable, they cannot be used as a key in a dict. That said, you can nest them as the values. So here we have a dict that has a list as one of the values and another dict as one of the values. The keys also have to be unique, and we'll get into that. You'll see an example of why they have to be unique. And then also shortly, you'll see why, because of that, you have to be very careful adding new dict items that you don't have duplicate keys, because you will essentially overwrite whatever that key's value was before in the dict. So we'll see that in action. But for now, let's create a few dicts. So there's a couple ways to do it. Similarly to lists, you can just use the curly brackets and literally put in the key value pairs like this. And just the curly brackets creates an empty dict. You can also use the dict method, which is just like the list method. It also has that same limitation of it can only accept one argument, and so therefore you have to put the key value pairs in within the curly brackets anyway. But as we saw before, this dict method can be good if you're trying to convert something into a dict. So typically I prefer to define dicts just with the curly brackets. Here is where you would convert something. So you can convert a list of tuples into a dict. And here's a good example of why tuples are immutable, because these two items will always be paired together. And you want to make sure that no matter what manipulation you do to this list, these two tuples are always paired together in the different elements. So it makes sense that if you converted this into a dictionary, that these items would then serve as key value, key value, key value pairs like that. So if you print this, exactly. Make sense? How the mapping worked there? Some confused faces. Sorry? Yeah.
Essentially, converted all the complex to.
Yeah. So if you here, let me make this a little bit more readable, and that might help. This is your list. Each of these tuples are an item in your list. See how when it creates a dictionary, it's more or less the same if you put them side by side. Each of these tuple pairs then become the key value pairs in the dict. Much easier to see with this, right? Okay. What?
What if there were three values in the bubble? Would people get confused?
I want to say that the last two values would become a list, but let's see. Yeah, it has to be tuples of length 2. I'll add that note in here. And then you can also combine two separate lists into a dict using the .zip method. So very similar to that. It's a little less stable, just given that you have to be sure that the lists are in the right order, like that they match up with the intended key and value pairs already. You know what I mean? So like you have to make sure that you actually want this value to match up with the first value here, the index position 1, index position 1 here to match up. But it's essentially the same thing. And so this would be an example where the dict is a string for the key and a list for the value. Yeah.
Just to be clear, if we wanted to say they weren't in right order, matched up, we'd have to, there's not a function we can use, we'd have to pop it. So,
I mean, unless you were gonna sort it or something like that, but yeah.
Can you sort it? Can you sort? This is
You can only sort them alphabetically or reverse alphabetically or numerically.
what if they each contain 4 values like this?
Oh, you mean the inner lists?
Yeah.
Yeah, you can sort the inner list.
And it would just be based on the first value of each.
You would, I'm sorry, you're
If you wanted to change the order, like shuffle around.
yes. Oh, yes. Yes, I see what you're saying. So you want to do something like this.
If we wanted the 1 4 to match the top.
Yeah. Yeah. So you would just do it like that.
First value of each one.
Yeah, it takes the first value in each one. Since you wanted 100s to match, I made it reverse since 100 is the highest. But let's say you wanted this one to match, or no, that's a bad example because that's the lowest. Let's say you wanted 86 to match. There's no one function to do that. Oh, because that sort is in place. There you go. See, I always forget until I print it out and I'm like, oh, it's none. Oh, it's one of those in place functions. Yes.
I like his question, but the original print that you had that showed those values,
Mm-hmm.
if I wanted to sort just those values, would I have to pop it out, sort it, then reinsert it?
Mm-hmm. So if you wanted to sort this within, okay, like the nested list, I'm not 100% sure, but let's try it together. Okay. Yeah, that worked perfectly. Yeah, so you can just, and again, like, if you have these questions while you're coding, just try it. So that's basically what we're doing together here. You would just have to figure like, okay, well, if I wanted to do that, what tools do I have that I could potentially manipulate to get there in some way? Debugging. Okay. Let me change this so that if I undo these, yeah. So now what I did here is that I put this as index 1 because obviously this one, if you sort it, it'll just be the same. So you can see that nested sorting in this one, that example. So let's practice together creating a dict. Pretend you work for some news corporation and you want to make a dict representing which push notification categories that some user has opted into, user 1, let's say. So we'll create a dict called push opt-ins. And if we want to do that, what would be the first step? Start with the curly brackets. And then here you can just make up, I actually talked about this in the last class as like a real life example. See if anyone remembers of how you might structure this.
This one random having your key and then true or false.
Yeah, you could just make up like This is my breaking news newsletter. This person subscribed to it. This is entertainment. False. Let's say this person's subscribed to health and whatever else. Weather. What? False. So then you would use this basically to know if your editorial team was creating a push notification for some piece of breaking news. You would check each user and whether their subscription to breaking news is true or false, and then send it out based on that condition. So real life example of how you might use a dict. Although this would be as part of a larger structure of that user, but we'll get to that. We'll get there. All right, so accessing dict data is a little more complicated than accessing list data because there are no indices. It's kind of like a set in which the order doesn't really matter. You access each item using the key. The key basically serves as the index position, which is why the keys have to be unique. So the way you would do this is very similar to the list, where for the list, you put the index number in the brackets. Instead, here you just put the name of the key in the brackets to return the value. So here, state capitals, we want the capital of Massachusetts. So we do this, MA, the key, and it prints out Boston. The risk there with using that syntax is that if there is no key with that name, it'll throw an error, and then it'll just stop your program in its tracks. So the fail-safe to do that is to use the .get function. You can put in the key, the key as the first argument, and then the second argument, really you can put in anything you want. Usually people do the two brackets just to indicate that there was nothing there for that key. But it's basically just kind of a default notification character that you want to return. So here, Pennsylvania is not in here. So we do .get PA brackets, and it returns this because it didn't find it. Whereas up here, it throws an error. One really valuable thing about Dicts is that you have 3 separate functions to return just the keys, just the values, and then just the pairs as isolated groups with obviously .keys, .values, and then .items returns the pairs. You would think that .keys and .values return lists of each of those, right? But they instead decided to be idiosyncratic, and they return list-like objects, verbatim from the Python docs, list-like. What they return is actually dict keys and dict values objects. So if you print these out, you'll notice that even when it prints with this little object around it, around a list. And then I did type just to show that it would do the dict keys and dict values. So in contrast to lists, you can't access these values, each of the values in here, by index position. Even though it's only one-dimensional, you really should be able to. So instead, the workaround for that is just to convert it into a list. when you get dot keys and dot values. Kind of like this. So here, we converted it from dict keys into a list, and then that way you can print the items by index position. I don't know why they chose to do this, but these are the kind of details you have to dig through the internet to find. Same goes for isolating the key value pairs with dot items. It returns a dict items object, which looks like a list of tuples, but again, you can't access it by index value. So what you would do is then turn it into a list and then access it the same way you would access a list of tuples. If you're wondering why you would ever use dot items, because it's basically returning a collection of the key value pairs. That's what the dict already is, right? They come in handy for when you're doing loops. So we'll see how that works in Tuesday's class. Otherwise, just use the dict. Questions on these functions? All right. And then built-in operators. Pretty much we've got these two sections left, and that's all of dicts. So once we finish this up, I put a bunch of P sets in the homework, and I figured if we got to them in class, we could start them. If we didn't, that way it's already in the homework, and we can just finish whatever. All right, so for adding or editing items in a dict, you can add an item or replace an item the same way that you do for a list by defining it here with the subscripting in the brackets, and that will add it to the end. But more likely, because it's more flexible and dynamic, you'll want to use the .update key value method, particularly because this can take multiple key value pairs when you update it. So you can use, oh, whoopsie. Again, you have to put them in your curly brackets. Yeah, because otherwise it doesn't recognize what the hell that is. So that's good because then you can either type multiple key value pairs in here, or if you're passing in a variable that is a dict itself and has multiple key value pairs, you can just pass that straight into .update like this. So we've got our state capitals, got some more states to add there,
So that works like
and
this.
then, yeah, and state capitals. But what we just did here is we changed the capital of New Jersey to Hoboken because someone decided to put that in here, and now we overrode it because it said, okay, New Jersey exists in here. I'm assuming that you put the correct value in here and you just want to update it. So when you are merging dicts like this, you want to be very sure that you don't have any duplicates between the keys. One way to go about this would be, for example, using what we just learned about duplicates to do here. Equals state capitals dot keys. We want to return it as a list. More states. See. Print both of those just so we can see. Line 20. It's probably missing some. Oh, because I only commented out the first line. That would make sense. It was like, what the hell is the rest of this? So then I think what we can do is, this might work. Yeah. No, because each one, yeah. Yeah, that's what I was thinking. List and then set. Ah, here's what you can do. Gotcha. Thinking in real time. So I have the solution. What do you think I can do here? How do you think I can find the duplicates between these two sets of keys?
These like accounts.
Exactly.
That way,
hmm
How would it know that?
Yeah, how would it know what you removed, right?
Yeah.
So do. And solve this together. So what if you were to do length? Count each of these, 5 and 6, and then length of the addition. You'll see how many there are. And then I think actually the easiest way to do this would end up being with a loop. Yeah. How is that? Oh, because I didn't turn them into the, yeah, because I didn't turn them into the set. That makes sense. Okay. There we go. So you can see how when we turned both into a set, it removed one. Therefore, there must be one duplicate in here. I think the easiest way, though, would be to do a loop. So you know what? I will bring back this example in the next class and show how we would figure this out. Ruman, would you mind making a note of that, please? Adam, you weren't in the room. This is Talk's brother. Just in case you were wondering who the random guy is in the back. No, Talk's brother. All right. Yeah, I'll bring that back in the next class and we'll solve it using a loop. All right, so then if you want to remove items from a dict, dot clear, as you might expect, just empties the dict of all items. And then you can do dot pop key value, similar to dot pop from a list, but you can do this instead. And again, you would put this in place of the value, either because you don't know what the value of that key is, or in case it doesn't exist, kind of like we did with dot get. So here it removes it, and it's Phoenix. Questions?
Would that remove just Phoenix or would it remove the entire area of Phoenix from that?
It should remove the entire pair.
Okay.
So then,
Yeah.
yep. Yes,
I'm sorry. Actually, date update.
the dot update?
Yeah.
Yeah, of course.
Oh, it needs to screen it.
Yeah, yeah.
Sorry.
No worries. Any other questions about any of these functions? The last one is just dot pop item, which removes an arbitrary key value pair from your dict.
That's funny.
Why you might use this? You might use this, for example, if you're doing sampling, like random sampling for maybe QA purposes or something, and obviously this only removes one, but say you put it in a loop and you run it 100 times. Yeah, exactly. Yeah, although there is a statistics module that has like a sampling function, which makes that a lot easier, but you could do that if you didn't want to import the whole statistics function. You could use this 100 times or like for whatever. Use the length and then, exactly, you could use the length of the dictionary and then 25% of the length and make that the loop run that number of times to get 25% of your data. So yeah, odd, but actually useful. And I created another table for us, and I put just here dicts and lists side by side for what you can do with them. Dicts are not as flexible or dynamic as lists, so you can't do anything like finding the index or counting, joining, splitting. You can sort, but you can only sort the list of keys or list of values like that. And it's only after you separate it out of the dict. So it's really not the same thing. Okay, so we finished early, which is great. Like I said, what I did is the homework, which you can access on the Lecture 4 page in GitHub. I put a bunch of P sets in there, and I figured we'd probably finish early. We can start it now together, go over maybe if we get through the first 2 sections, and then that way it'll give you some practice with the dicts, and then you can just finish the rest. That way also, whatever problems you do in class, I can take a look at that code and comment on it. So win-win. Okay, so if everyone could just let me know when they've made a copy of the Homework 2 notebook. Cool. Start with the dict ops section, because that'll give you some practice on basic dict work. And that way, if we can go through that together in class, you'll be in a good place for finishing the homework by yourselves. Yeah, so there are 5 problems in that. Let's say, I don't know, 15 minutes, 20 minutes? What do you guys think? Let's start with 15 and see where we are. Sounds good. Yeah, these are the, I'm not going to show the answers. No, but here, I'll put this table up here for reference so that people can see, right? It should be helpful.
What was that, I didn't correct the syntax.
Oh, it's testing against the list.
Wait, what?
Because it comes out as a list.
I thought it was a tuple. Yeah.
So how is everybody doing? Approximately what number? 3? Okay. Do you want like 5 more minutes and then we'll go over them? Or do you want to just go over up to problem 3 now?
I have a question about 3.
Mm-hmm.
I'm doing it right.
Okay, why don't we go through problems 1 to 3 now together, and then maybe that will help with problems 4 and 5 when you guys do those and things like that. All right. So problem 1, basic dict concepts. Declare an empty dict, as D1, just the curly brackets. Contain or create a dict.
The first question for me is phone numbers.
Yes, of course, this one.
I'm sorry,
Oh.
are you doing the wrong section?
That was my bad. I didn't listen to the instructions.
You did what?
I didn't listen to the instructions.
Oh, that's okay.
Yeah.
Yeah, I was like.
Did you have a question, Femi?
No, I did the same thing, I was just thinking about
Oh, okay. Did anyone else also start with the list manipulation problems? Okay. I'm gonna go over these first few
That's fine.
dict problems because it will benefit you anyway. Okay. So part B of problem 1 is just create a dict with these names that I had listed here in the comment. So just like this. Part C is to add this person's name, Allison Zhang, to D2. So you use .update, and the part that is most forgotten is that you have to add this key value pair within the curly brackets, within the .update function. Very important. Otherwise, it won't understand that this is supposed to be taken as one argument, like one key value pair. Part D, how many people are now in D2? and print out all their first names. To find out how many people, all you have to do is find the length of D2. That gives you the number of items in the dict. And then to print out their first names, you would just do D2.keys, because you know that the keys stand for their first names. If you wanted to delete a random person from D2, you would just do D2.popItem. Then for part F, re-add the name you deleted to the end of D2. If you assign this to a value in part E, the pop item, the item that gets popped out gets assigned to X or whatever variable you call it, and then you just pass X into .update. And actually, Adam, what you were looking at before, remember how we passed in test?
Yeah.
And it didn't work?
Yeah.
Looks like you have to pass in the variable within the curly brackets, and that's easier.
You can't treat it as a one.
You should be able to try that again. Tell me if it works. Yeah? Okay.
Maybe I put the curly brackets outside of the.
I don't know, but if anything, you just learned a hack way for to do it differently. No, this is much easier, though. So this one is kind of like these last two parts, E and F, are reminiscent of the list problem we did before, where it was like remove one item, re-add it to the end. Remember? Michael, did you have a question?
I'm missing that update for me is not working.
In part F?
C.
Part C. So did you format it exactly like this? Here, let me make this a little larger. Where you have Allison, colon, Zhang within the curly brackets. Uh-huh. I will hold on to that thought.
Okay.
I will come over after we go through the other two problems. Or that works too.
You would add what do you call it? A bracket, it adds brackets,
Yeah, you got it to work?
Yeah.
Yeah, it's always something like that. Yeah, I noticed that when if you're like adding a function within another function that you've already written, what it will do is it will take the ending parenthesis of that function. So like if I wanted to do something like this, right? Sum within that len function, when I type the ending parenthesis for this inner function, it just overwrites the parenthesis for that outer function. And yeah, then you end up with some missing parenthesis and it screws itself. All right. Problem 2, merging dicts. Very simple, just pass it as an update. This one does not have the duplicate keys that we saw earlier, so no need to worry about that here. Problem 3 was a rather complex one, but I think a really good example to get you into the nitty-gritty with dicts. So let's say you are a Girl Scout troop leader, apparently. You've got 3 girls, Wendy, Connie, and Francesca, and you had them this year selling 3 types of cookies, Tagalogs, Thin Mints, and Samoas. So each girl has a dict containing the type of cookie and how many of that cookie or how many boxes of that cookie they sold this year. So part A wants you to print out the number of boxes of Girl Scout cookies that each girl in the troop sold that year. So what you would do is get the values from each of these, turn them into a list, and sum them. Questions on that? Here, I'm gonna comment this out and just print that for now. So the result for part A would be something like this. Or it should be exactly this, actually. For part B, you want to know the total number of boxes sold amongst the girls for each type of cookie. So the total number of tag-alongs sold between these three girls, et cetera, et cetera. So what you would do here is reference each cookie type from each girl, which will give you the value. It'll return the value, the number of boxes sold. And if you add those three together, the total number of boxes of that type of cookie sold. So let me just comment this out so we can isolate that. Does that make sense? People follow that? Questions? It's all just about thinking, like, how do I parse this up? For part C, you want to know for each type, the total of each cookie that you just found in part B and divide it by 3, because 3 girls. And then you would get the average of them. Or 3 types of cookie, not 3 girls. For part D, you just want to print out the total number of boxes of all the cookies and all the girls. So you could just take the sales from each girl that we found earlier and add them together. Or you could take the total number of each type of cookie and add those together. Either one will give you the total number of boxes sold. Questions on this problem? Okay, good. This one gets you nice and intimate with the dict. Okay, so we're about up. I will be here for office hours if anyone wants to stay. And you should have just gotten a link to the exit ticket on Slack. So please fill those out. Does anyone want to stay for office hours today? No pressure. Yeah, question?
First, why are we going to start with the using the projects?
The project?
Yeah.
So you've got loops, functions, and classes. You've got 3 more core Python topics. After that, you'll go into data science, and then that lesson on like the introduction to data science is when you'll talk about what the project specifications are.
Cool.
So maybe 3 or 4 more lectures, depending on how fast those topics go. These?
Yeah.
I will. This is the homework answers. So I will share these Tuesday. When the homework is due, we'll go over all of them together, and then I'll give the answers to everyone. And then obviously the homework is just to finish all the problems in here.